Sometimes in a covalent compound, all the atoms are neutral, but sometimes one or more of the atoms might have a formal charge. This is like when a single atom loses or gains electrons to become an ion, just within the context of an entire molecule, due to the way the electrons are distributed amongst the atoms. If an ammonia molecule behaves as a base and picks up a proton, it will become the ammonium ion, in which the nitrogen has a formal positive charge. How can we look at a structure and be sure we know the charge on each atom? One way to go about calculating the formal charge on an atom is to take its typical number of valence electrons, that's 5 for nitrogen, and compare it to the number of electrons it is contributing to the Lewis dot structure. For ammonia, nitrogen is contributing 1 electron in each bond, plus the lone pair, that's 5. But for ammonium, it's just 4, 1 per bond. 4 is 1 less than its typical valence of 5, and 1 fewer negatively charged particles must mean the nitrogen will have a formal positive charge. Another way of calculating this is by saying that the formal charge will be the number of valence electrons an atom normally possesses, minus the number of lone pair electrons, minus 1/2 the number of bonding electrons surrounding that atom. For ammonia, that would be 5 minus 2 from the lone pair, and the 6 electrons in the covalent bonds divided by 2 is 3, giving us 0, or a neutral charge for that nitrogen atom. For ammonium, it's 5 minus 0 minus 4, which is why there will be a +1 charge. Looking at ICl4-, we can use this method to determine the formal charge on the iodine atom. First, we will have to draw the correct Lewis dot structure, which would be as follows. Now, iodine will typically have 7 valence electrons. Let's subtract the 4 electrons in lone pairs to get 3, and then subtract half the number of the electrons in the covalent bonds it's participating in, which would be 1/2 of 8, since there are 2 per bond, which gives us 4. And all that will give us 1 minus as the formal charge for iodine. Once again, a slightly more straightforward approach is to compare the number of valence electrons an atom typically has to the number it is contributing to a particular Lewis dot structure. Iodine usually has 7 valence electrons, but it is contributing 8 to this particular structure because it provides 1 electron per bond. That's 4 plus the 4 from the 2 lone pairs for a total of 8. 8 is 1 more than 7, and 1 more negatively charged particle means a formal charge of -1. This can work well for tricky examples like carbon monoxide. If we go by this Lewis dot structure, what will be the formal charges on these atoms? Well, carbon usually has 4 valence electrons, but it's contributing 5 in this structure, 1 per bond plus the 2 in the lone pair. 5 is 1 more than 4, so it will have a -1 charge. Oxygen usually has 6, but here it shows only 5. Again, 1 per bond plus the lone pair. 5 is 1 less than 6. 1 fewer negatively charged particles will mean an overall +1 charge for oxygen. The formal negative charge on the carbon and the formal positive charge on the oxygen will cancel each other out to give a neutral molecule overall. And now we know how to assess formal charge.